All right, let's get started. Good morning. That was a fine response, thank you. I'm Brad Caskey, and I serve as the Provost and Vice President for Academic Affairs here at Birmingham Southern College. Excited to welcome you to today's Provost Forum. And before we begin, we always do a little public service announcement. You will notice in the back of the room there's someone who is videotaping this. So if you're sitting in that area right there, please keep your comments on mute, otherwise they will pick you up instead of the speaker. So let's get going. It's now my distinct pleasure to welcome you to today's forum, presented by Dr. Scot Duncan. Dr. Duncan is a professor of biology who joined Birmingham Southern College in 2002. His academic credentials include a BS from the Eckerd College, I have a Z for you, thank you, and an MS and PhD from the University of Florida. His research specialties include plant, forest, stream, and avian ecology and conservation biology, and his work has taken him from the tropical rainforest of Uganda to the Dolomite Glades of Bibb County. Please join me in a round of applause when we bring Dr. Duncan to the podium for his presentation, Confluence, Hope for the Southeastern River in the Anthropecene.
All right, thanks everybody for being here this morning. Can everyone hear me? In the back row? That's good? All right. So I'd like to begin by thanking the administration for continuing to support the sabbatical program. Such opportunities keep the faculty engaged so that we can give our best to the students. I'd also like to thank my colleagues in biology, there you are, for the extra work they took on to cover for me while I was away on sabbatical. And thank you all for being here today. I get pretty excited about biodiversity, the variety of other species with whom we share the planet. I feature biodiversity in all my classes. I speak to the public about it. I even enjoy searching for uncommon species in what little free time I have, for birds especially. Why this fascination with nature? Part of it is entertainment. I enjoy the adventure and seeing species and landscapes that I've never seen before. But there's another reason, one that's more sublime. There's more diversity of species, ecosystems, and landscapes on our planet than one can imagine. This fires within me a sense of wonder about the universe and our fate to be marooned on this little blue dot with so many fascinating neighbors. There are also more practical reasons for why I care about biodiversity, and they stem from my deep love and concern for humanity. And here's the connection. Despite all our technology, we humans are inescapably dependent on biodiversity and ecosystems for our survival. Rivers provide drinking water. Ocean plankton and forests provide the oxygen we breathe. Insects pollinate our crops, and predators keep pest populations in check. These things that nature does for us are called ecosystem services. And the main lesson from ecology, the science of ecology, is that ecosystems provide more services and better quality services when their native species are present and their populations are healthy. Each of us is alive because of millions of unseen organisms out there in nature doing their jobs. Unfortunately, the news these days about biodiversity is not good. Our amazing success as a species has been costly to other species. We've cut 50% of our planet's forests. Since the 1970s, wildlife populations on land and in the oceans have declined 60%. Hundreds of species have been lost to extinction, and thousands more are endangered. These are symptoms of ecological decay, and when it goes too far, the results can be ugly. Wildfires in California, water contamination in Flint, Michigan, flooding in Houston from Hurricane Harvey, destruction in Florida from Hurricane Michael. Ultimately, such disasters are a consequence of ignoring ecology and undermining ecosystem services. In short, biodiversity matters, and it matters a lot. So when I speak up for it, I'm really addressing a collective existential crisis. When I moved to Birmingham, the area was new to me, and I had to start learning from scratch the species and ecosystems here. Much to my surprise, I learned that Alabama was a superstar in biodiversity. It has more species than any state east of the Mississippi River, and is ranked number 5 among U.S. states. Unfortunately, it has seen more extinctions than any state other than Hawaii. When I was eligible for my first sabbatical in 2009, I tried something new. Instead of taking on a new science project that would likely have little impact, I undertook writing a book for the public. Southern Wonder came from a desire to reach and inspire more people to care about Alabama's biodiversity. It was published in 2013 and has been well received. Educators, environmentalists, nature lovers, and other scientists used the book to help them better understand the state's biodiversity. It has empowered people to connect with nature and be stronger advocates for its protection. So, when I was up for my second sabbatical in 2017, I decided to start another book, because it's probably the most effective way I can promote conservation. I chose to write about southeastern rivers. The region is a global hotspot for river biodiversity. It has more species of freshwater snails, mussels, crayfish, and turtles than anywhere else on the planet. And it has more species of freshwater fishes than any other place outside the tropics. I aimed to tell stories about the strange and beautiful species that we have and what's needed to ensure that we don't lose them to extinction. What's more, I knew that our rivers are important to the economy. Should our rivers fail, we would lose our ability to generate electricity, provide drinking water, and feed ourselves. It's cliche, I know, but water truly is life. This book ideas all seemed straightforward to me at the time. What I did not know was that I was soon to learn about a threat to our rivers that was so disturbing that it hijacked the direction of my research and writing. Now, I don't know what you know, so let's begin with a few basics. Rivers are channels in the landscape that bring surface water to the ocean. The land a river drains is known as a watershed, and the secondary channels feeding a river are known as tributaries, though I'll sometimes just refer to them as streams. The area I focus on is an eight-state region outlined here in yellow. The rivers here have never really received the attention they deserve, given their importance for all who've lived in the Southeast for the past 20,000 years. And our rivers are also exceedingly beautiful. They include the Suwannee River in Florida, the Cahaba River right here in Alabama, and the French Broad River in North Carolina. Now, rather than write a pedantic review of the region's rivers and threats, I chose a few species to feature as characters and have woven their biology into a series of stories that carries the reader through the book. Today, I'll introduce a few of these characters and share with you the book's main message. One of the chief protagonists is this fish, the sturgeon. Some refer to it as the dinosaur fish because sturgeon have been found as fossils dating back 100 million years. It's definitely odd. Note the bony plates on its back and the whisker-like barbels dangling from its snout. The Alabama sturgeon can grow to 14 feet in length and weigh over 800 pounds. In the Gulf of Mexico, we have the Gulf Sturgeon. It's smaller, though it still reaches an impressive 8 feet in length. These two species are also unusual because they are anadromous, meaning that they spend most of their time in marine waters that migrate up rivers to spawn in the spring. Like salmon, sturgeon spawn only in the rivers in which they were born. Unlike salmon, sturgeon don't die after spawning, but the process is exhausting and it takes them 2 to 3 years to recover before they can do it again. Sturgeon were incredibly abundant back in the day. Their spring migration runs sustained many Native American villages along the rivers of the eastern U.S. The runs occurred during early spring when winter food supplies were running out and the summer bounty had not yet arrived. A few Native Americans could capture and smoke enough sturgeon meat to feed a village for many weeks. Perhaps you're familiar with Jamestown, Virginia. It was the first permanent English settlement in the Americas. Turns out that sturgeon migrating up the James River are credited with saving the Jamestown colony during the early years when starvation was so bad that many were dying and some even resorted to cannibalism. Yum. Whereas Native Americans used weirs, nets, and even found sport in wrestling sturgeon to shore, the colonists waded out into the rivers and awkwardly jabbed at sturgeon with swords or clubbed them with frying pans. Whatever works, right? Now, chances are, if you've heard about sturgeon before today, it's because of their cured eggs known as caviar. Caviar has been a delicacy prized in Europe for many centuries. Now, Euro-Americans overlooked sturgeon as a food source for several hundred years. As for the caviar, no one had discovered a method of preserving sturgeon eggs for shipment across the Atlantic. But the fate of the American sturgeons changed in 1870 when a German immigrant named Benedict Blom established a curing method for American caviar, and he marketed it to major U.S. cities in Europe. His impressive financial success quickly spelled doom for the species. Soon, vast amounts of caviar were being harvested and sold. Migrating sturgeon in northeastern rivers were met with wall after wall of net. Unbelievable amounts of sturgeon were captured and butchered for their caviar, meat, and oil. As populations were depleted, fishers moved on to other rivers, over time working their way farther and farther south and into the Gulf of Mexico. Side note here, my great-great-uncle was a sturgeon fisherman in Pensacola and Choctawhatchee Bays. Anyway, eventually both the Atlantic and Gulf sturgeon were driven nearly to extinction. We'll learn more about sturgeon in a few minutes, but first I want you to meet another main character of the book, the river mussel. Mussels are clam-like creatures, brown and lumpy on the outside, soft and squishy on the inside. It might seem that they're not particularly interesting. But mussels provide a valuable ecosystem service as they filter the water for food. Dirty water goes in, clean water comes out. One mussel doesn't do much, but our rivers were once paved with mussels, quite literally, sometimes numbering several hundred per square meter. Each mussel filtered about 12 gallons of water a day, and that added up quickly. Though the Southeast has several hundred mussel species, early Euro-Americans had very little use for them. That changed in 1857 when carpenter Jacob Quackenbush discovered a magnificent pink pearl near Powderson, New Jersey, and sold it to Tiffany & Company for $1,500, a small fortune at the time. News spread and pearl fever swept across the U.S. Each mussel was a lottery ticket and rivers were giving them out for free. Though only 1 in 10,000 had a marketable pearl, the allure of easy money called people of all backgrounds to the river. Pearl rushes decimated mussel populations in many areas, but what really hit them hard was the button industry. Back before plastics, buttons were made out of shell, bone, and other natural materials. In 1891, Johann Biebel, another German immigrant, established the first shell button factory on the Mississippi River in Iowa. By the end of the decade, there were 70 button factories just in the Mississippi River Valley and dozens more beyond that. Whereas pearling was an artisanal pursuit, button production from mussel shell became a true industry. Thousands of shellers made their living collecting mussels, and thousands more worked in the factories. The biomass of mussels harvested during the industry's heyday is simply mind-blowing to anyone familiar with how rare mussels are today. At peak harvest in 1912, 500 million mussels were extracted from streams across North America in just 1 year. This level of harvest, of course, could not be sustained, and by 1920 the pearl button industry was in free fall. The pattern is similar to the exploitation of sturgeon and dozens of other species inhabiting North America at the dawn of the Euro-American conquest. A useful species was discovered, a market developed, and overharvest commenced, sometimes driving species to extinction. Today, mussels are the most endangered group of organisms in North America, and possibly in the world. But so what? What have we really lost? As for the sturgeon, we've lost a tie to our historic past, a lucrative resource, and a migratory spectacle that would be amazing to witness. As for the mussels, well, they filtered water and kept it clean. The loss of mussels is one reason why river water is typically brownish-green today instead of clear. And consequently, we spend more money cleaning river water for drinking than we would if mussels were gone. So when we lose biodiversity, we lose valuable ecosystem services. Fortunately, there are efforts to bring mussels back, and there have been a few successes. But really, why bother? We have plenty of cultured pearls and plastic buttons like the one on my shirt. So who would bother protecting mussels from extinction? Well, it happened like this. After World War II, the proliferation of new technologies, and a population growth spurt, the American economy was booming. Consumers had far more options of stuff to buy than ever before. But then, just as now, behind every gadget or can of soup, there's a production line where natural resources are gathered and converted into the raw materials for manufacturing. The environmental problems created here are numerous. First, the gathering of raw materials and production of food does considerable damage to the natural world. There's mining, fishing, deforestation, and agricultural expansion. Ecosystems are destroyed, and species are harvested or killed as collateral damage. Secondly, a lot of waste is produced in the process, and we put this waste right back into the environment. Air pollution, water pollution in landfills, and more damage to ecosystems and species. People are sickened by this pollution as well, but not just anyone, usually those of the lowest socioeconomic strata. This is one of the many intersections between conservation biology and social justice. By the late 1960s, the condition of the environment in the U.S. was terrible. The skies were dark with air pollution, rivers were thick with sewage and industrial waste, and a few were even catching fire. Conditions got so bad that environmental health became a concern for many. Not just hippies and tree huggers, but your average American. Environmental activists publicized these problems and generated media attention. Eventually, there was enough demand for action that in the early 1970s, environmental legislation was crafted by Congress and signed into law by Richard Nixon. This included the Clean Water Act, the Clean Air Act, the National Environmental Policy Act, and the EPA, the Environmental Protection Agency, was created as well. These laws and others set nationwide standards and gave the federal government considerable power over states to oversee their enforcement. As a result, the water in our rivers and the air we breathe is cleaner today than it was back then. So the next time you hear someone complaining about the federal government's involvement in the free market in our lives, remember that many of us and the people we love are alive and healthy today because these laws have prevented millions of cancer cases and other illnesses. Now back to mussels. One of the laws passed in the 1970s was the Endangered Species Act, designed to prevent further extinctions. For species close to extinction, federal funding is allocated to fund programs to help them recover. There have been many notable successes with the Act, but very few with endangered mussels. Despite cleaner water and no more pearling or button factories, mussels have failed to recover. It's still somewhat of a mystery as to why, but for sure, one of the main reasons for their predicament is a very strange practice of theirs. Sedentary aquatic species, such as corals and sponges and barnacles that don't move around much, or at all, they typically have it easy when it comes to raising young. Male and female pump their sperm and eggs into the water, sperm and egg meet, and the young larvae drift in the water until they're ready to settle on the bottom. Easy enough if you live in an ocean or a pond. But this doesn't work in rivers, where the current would quickly take larvae out of the habitat where they could survive as adults. So to help the young fish stay in the right ecosystem, female mussels trick fish into babysitting their young while they mature. They create enticing lures to draw fish near. Some lures even look like minnows or crayfish. And when a hungry fish takes a bite, the lure explodes in the fish's mouth, and the larvae clamp down on the fish's gills and hang on until they're ready to drop off and sink to the bottom a few weeks later. Other mussels will spray larvae into the face of fishes when they investigate the lure, and a few species actually trap the fish between their shells to get this done. Overall, the fish is generally unharmed in the process. Now, these are very highly specialized relationships. About 80% of mussel species use just one or two fish species to take care of their young. Now, this worked fine in a world where fish populations were healthy. But river fishes have declined precipitously, and this seems to be a major barrier to mussel recovery efforts. For example, meet this guy, the purple bank climber. By some respects, it's a typical mussel in appearance. It used to be found throughout the lower Apalachicola Basin and Ocklawakanee River to the east. But now it is rare, and only one has been seen in the entire Chattahoochee River since the 1800s. Some populations remain, but most consist of old mussels. Young mussels are rare, suggesting that something is interfering with reproduction. The species is considered threatened now, so identifying the barrier to recruitment could help the species recover. But until recently, the fish host for the purple bank climber was unknown. Then after a decade of research, there was a breakthrough in 2012. The host for this mussel turned out to be none other than this guy, the Gulf Sturgeon. a species that itself is threatened. Talk about bad luck. With only a few hundred sturgeon left in this river system, it's no wonder the mussel is disappearing. This, of course, illustrates how ecosystems unravel. When one species is lost, many others are affected. As they say, everything is connected. So if we want to bring back the purple bank climber, we also need to bring back the sturgeon. It's the same story for dozens of other mussels and their fish hosts. So, what's the status of the sturgeon after all those environmental laws were passed nearly 50 years ago? Well, there's reason to expect that sturgeon would have recovered. There have been fishing bans on them for decades, they're federally protected, and sturgeon can be prolific breeders. But sadly, both the Gulf and Atlantic sturgeon remain on the endangered species list. And here's why. This is a dam. Dams are one of the principal antagonists in my story. They are the pinnacle of river industrialization. We've been building them for centuries on the smallest of streams and the largest of rivers. There are about 30,000 dams in the Southeast. That's one dam for every 2,800 residents. We use dams to prevent flooding when we've unwisely settled in river floodplains. We use dams to create reservoirs deep enough to allow river transportation. Reservoir water is used for cities and farm irrigation. At hydropower dams, water spins turbines to generate electricity. At nuclear, coal, and gas-powered electricity plants, we use reservoir water as a coolant. You might expect that these purposes would be enough to explain why we have so many dams. But no. 70% of dams in the Southeast have been built primarily for recreation. It's an important but non-essential use of rivers. Now, from an ecological perspective, dams are catastrophic. They disrupt the seasonal flow of water on which wildlife depends for feeding and reproduction. They withhold sediments needed to sustain ecosystems downstream. Reservoirs create conditions in which river species cannot survive. And dams prevent fishes from migrating. It's not just sturgeon and salmon. Many fish species migrate dozens to hundreds of miles upstream each year to gather in suitable places for spawning. So you don't need a PhD to deduce correctly that dams are possibly the top reason why there are so many endangered freshwater species in the Southeast. As for sturgeon, dams now block them from reaching most of their historic habitats. This is likely the main reason why sturgeon have failed to rebound. So if we want to save mussels, then we must save fishes. And if we want to save the fishes, then we must do something about dams. Now, dams are controversial for many reasons, not just biodiversity. Whenever one stakeholder takes control of the water at the expense of others, there's going to be conflict. Mill dams built for grinding grains in early America often triggered protests for disrupting transportation routes on streams and rivers and blocking the migration of the American shad, a fish that many settlers depended on for sustenance. It's no different today. Cities want water for municipal supplies, farmers want it for irrigation, industries want water for manufacturing and power generation. In wet years, there's plenty of water to go around, but droughts are a frequent feature of southeastern climate, and they can quickly deplete our water supply. Water scarcity isn't just a thing for places like California. It's an issue right here in the Southeast and has been for decades. The poster child for this is Atlanta. Dr. Gammon spoke of this in his Provost Forum recently. Georgia and Florida have been battling in federal courts over control of the Ecological Flint River system for several decades. Georgia wants drinking water for Atlanta. Florida wants that water to sustain oyster and crab fisheries in Apalachicola Bay. Alabama? Well, we wanted to say how much water we get, but we were quickly shut out of the legal process because Alabama doesn't have a water plan. It's the only state in the Southeast that doesn't, and thus cannot say how much water it needs nor why. Now, before this project, I knew that water scarcity was a problem in Atlanta and a few other communities in the Southeast. But when I looked into it further, I was stunned to learn that water scarcity is about to become a lot worse in the region over the next few decades, and for reasons I didn't see coming. That reason? Climate change. I've been paying attention to climate change since the late 1980s. And as climate science improved and the predictions became more refined, I've grown increasingly concerned about the future of biodiversity and our future. However, I didn't know much about the changing southeastern climate until I read this report. Every 4 years, the U.S. Global Change Research Program reports to Congress on our latest understanding of how the changing climate is affecting and will affect the U.S. The National Climate Assessment is authored by hundreds of experts from 13 federal agencies, plus scientists outside the government. The 2014 report included a detailed look at the Southeast, which was published as this separate report you see here. What I read here rocked my world and hijacked the direction of my research and writing. Now, before I go any further, it's important for you to know that profound changes are already baked into the future climate. We have already added enough carbon dioxide to the atmosphere that our climate is undergoing changes that will continue well into next century. And of course, the longer we continue our use of fossil fuels for energy production, the worse the situation will get. Many regions of the world are being hit hard by these changes already, and the U.S. is no exception. Perhaps you're aware of the melting permafrost in Alaska, or droughts in California. But here in the Southeast, we're expected to have more negative economic consequences from climate change than any other region in the U.S., and for reasons that include everything from heat-related illnesses, to impaired transportation, to storms, fires, and floods, and higher energy bills due to increased air conditioning use. Importantly, the warming trend will also diminish our water supply. And this is where I found climate change and rivers colliding. We are headed for more frequent episodes of water shortages in the coming decades for two reasons. First, the population in the Southeast continues to grow. People are still moving here. And more people means more water consumed from our rivers and aquifers. Second, the warmer temperatures caused by climate change are leading to more water lost to evapotranspiration. This is the water that's lost from our soils or our rivers and reservoirs via evaporation, as well as water pumped into the atmosphere by plants. This also means less water seeping into our underground aquifers, on which we also rely for water. Now, shortages in the region will vary from little to none along the immediate Atlantic coast to losses of 5 to 7% in the central south and westward. Stream flow will decline from 5 to 25% across the region. Now, these numbers may not sound like much, but that's just in the next 40 years. Climate change will continue far into the next century and beyond. And these are also just averages. The swings in water supply from year to year will be much more dramatic than in the historical past, and in fact, they already are. The Southeast is already prone to having very wet and very dry years naturally. But due to climate change, our dry years will be much drier, and some will trigger long droughts. Droughts are a regular occurrence in the region, and they have increased in frequency and now strike faster and harder. Water shortages are a significant threat to biodiversity in our southeastern rivers, of course. Already it is a challenge to maintain enough water in rivers to sustain the species we still have. During periods of water shortage, this will be even harder due to more intense demand for water for drinking, irrigation, power production, and industry. All this could spell doom for our river ecosystems and their biodiversity. Climate change, rivers, and the future of the Southeast also collide dramatically at the coast. Ice is melting rapidly from glaciers and ice caps, and that means more water in our oceans. At the same time, water expands as it warms, so as oceans absorb heat, they also swell. How much sea level rises depends on whether and how quickly we reduce CO2 emissions. Under the best-case scenario, where global CO2 emissions peak by the year 2020 and decline to around zero by 2080, we'll see about 1 to 2 feet in sea level rise by the year 2100. That's not good, but it's tolerable. Under the business-as-usual model, the track that we're on now, of course, we will continue the pattern of relatively unchecked CO2 emissions. We will see 2 to 4 feet of sea level rise. And if recent estimates of accelerating ice loss in Antarctica and Greenland continue, an additional 2 to 4 feet on top of, add an additional 2 to 4 feet on top of either scenario. To make matters worse, some portions of the world, such as the Southeast Atlantic coast, are actually sinking at the same time, so relative sea level rise is much faster and higher. Now, sea level rise doesn't manifest as simple flooding. The first effects that we are seeing is a rise in what are called nuisance tides. These are high tides that exceed normal levels and flood urban areas. Parts of Miami Beach are famous for now being inundated regularly during these sunny day floods. The southeastern Atlantic coast cities are also vulnerable. This graph shows one of the many locations on the Georgia coast that's already dealing with this problem. Wilmington, North Carolina, and Charleston, South Carolina now see over 40 and 25 nuisance floods per year, respectively. And it's going up as the years go by. Know that today's nuisance floods will be tomorrow's high tides as sea level continues to rise. The other impact of sea level rise is the flooding caused by hurricanes. Already, hurricanes are more powerful and damaging than they were last century due to climate change. Winds are stronger, the storms deliver more rain, and due to sea level rise, the surge of ocean water that comes ashore is higher. These storms cause loss of life and billions of dollars of damage. These impacts will increase as the climate warms, sea levels rise, and hurricanes become stronger. But what does all this have to do with rivers? Well, the coast needs healthy rivers to help it adapt to climate change. Sediments delivered to the coast by rivers build up ecosystems such as beaches, barrier islands, swamps, and salt marshes. These ecosystems are our first line of defense against sea level rise and hurricanes. The delivery of fresh water to the coast is also important. As sea level rises, it brings ever saltier tides farther into our river deltas. These salty tides damage the marshes and swamps protecting the coast. These ecosystems also sustain wildlife, including the young of valuable seafood species such as shrimp, snapper, crabs, and oysters. Freshwater delivered to our coast by rivers pushes these tides back and buys ecosystems time to grow and keep up with the rising sea levels. So the coast needs river water and sediment like never before, yet we face a future where there is less water to go around. As you can see, there are plenty of reasons to be worried. I'm not talking of some distant future for a generation not yet born. The future is here now. But despite these challenges, I'm optimistic we will meet this future with ingenuity and grace. By some measures, we can come out stronger than we are now. And we can save our southeastern rivers in the process. Here's how. When we start talking about water shortages, the first solution many will think of is more dams. This could seem perfectly logical, right? If there's less water running through our rivers, then we should better capture it and hold it for later use. But here's the thing. Dams are expensive to build. Most water supply dams cost tens of millions of dollars to build. And huge cost overruns are the norm, not the exception. And where does this money come from? Well, it comes from us, the taxpayers and the ratepayers. Communities that in recent years have built dams to supply water are now burdened with expensive monthly water bills and municipal bonds to service for decades to come. In addition, during dry summers and droughts, when we need our water the most, evaporation from reservoirs increases, so we lose much of our stored water to the atmosphere anyway. There is an alternative. It's the untapped potential of water efficiency programs. Water efficiency is doing the same thing that we do with water now, but doing it with less water in the future. Water efficiency programs are cheap. New dams and reservoirs can cost up to 8,500 times more than water efficiency policies per gallon of water made available. What's more, water efficiency programs can work very well. Take Atlanta. Since the year 2000, the city's population grew by 25%, adding over 1 million people. And yet, during that same time, Atlanta has seen a 10% decline in water use and a 30% decline in per capita water use. This was achieved by such measures as toilet rebate programs, repairing leaks, and discouraging lawn watering. It is smart strategy to reduce our need for water at the same time that our supply is shrinking. And the less water we use, the more water stays in our rivers. It's good economy, and it's good ecology. There's also reason to hope that we will have many fewer dams on our rivers by the end of this century. Here's why. Dam building in the U.S. peaked in the 1970s and has declined ever since. The decline is due to the high expense of dams and stronger environmental laws. This means that most of our dams are old, and as they age, they are growing increasingly dysfunctional and dangerous. Dams fail, and the results can be catastrophic. Thousands have died in the U.S. as a result of dam failure. While deaths are now rare, about 20 dams fail each year, and another 75 would have failed without intervention. The U.S. Army Corps of Engineers tracks 91,000 mid-sized to large dams in the U.S. Of those for which the construction date is known, 70% will be at least 50 years old by next year. And about 85% of all dams in the U.S. are nearing the end of their planned operational lives. Old small dams are a threat on our rivers as well. This one in Wilmington, North Carolina has killed 18 people since 1984. Several were children. There are hundreds of other killer dams throughout the Southeast. For these reasons, already 1,400 dams have been removed in the U.S. as of 2017, and that's mostly over the last 2 decades. As dams come down, this will improve connectivity in our streams, allowing fishes and aquatic animals to migrate again. More fishes means more mussels, and more mussels means cleaner waters and fewer extinctions. Fewer dams also means more water and sediments delivered to the coast to combat sea level rise. Most of the dams that have been taken out so far are small. They're cheaper to remove and involve fewer stakeholders. But what about the big dams on our rivers? Most are associated with power generation, not just hydropower, but also dams built to withhold water for nuclear, coal, and gas electricity plants. These large dams have the biggest negative impact on natural river functions. But are they here to stay? Not necessarily. Several large power dams have been taken down in the Pacific Northwest, and the removal of several more is being planned. I expect we'll see similar removals here in the Southeast by the end of this century for several reasons. Already our hydroelectric dams are expensive to maintain, and as they age, the cost of upgrading and repairing them will rise. Meanwhile, the cost of clean energy is dropping. And when those curves cross, dams will be more of a liability than they are an asset to the utilities that own them. In addition, many of our coal plants that depend on reservoir water are closing because they're losing profitability. Their machinery is old and inefficient, and the cost of keeping up with federal clean air policies is high. So many utilities are closing coal plants and replacing them with gas plants. Gas plants use 1/4 of the water for cooling. So compared with coal, gas is cheaper, safer, and emits 50% less carbon dioxide. There's also growing demand for renewable energy, particularly wind and solar. That demand is coming from progressive voices in our citizenry and influential voices in business. For example, before Facebook agreed to build a data processing center near Huntsville, Alabama, they demanded a supply of clean energy. The Tennessee Valley Authority is now constructing 2 large wind farms to provide that power. Thus, in terms of the removal of large dams in the Southeast, it's not a question of whether, it's a question of when. Now let's step back and take a look at the big picture. I've hit you with a lot in the last few minutes, and a lot of it's pretty grim. But I'm afraid that this is part of our collective awakening to a new era for our planet. Scientists are calling it the Anthropecene, to acknowledge that we humans are now planetary change agents. The evidence for the new age is overwhelming. Our chemicals are burning through the planet's protective ozone shield. We've triggered another mass extinction event. We've transformed most of the world's productive landscapes into agriculture. We've retained most of the world's liquid freshwater behind dams. Pollution is detectable in every corner of the earth. We've greatly distorted the world's nitrogen and phosphorus cycles, and we've changed the climate of the entire planet so that temperatures are increasing, oceans are rising and warming and becoming more acidic, and storms and droughts are becoming more intense. None of this was intentional. Instead, we have unexpectedly and awkwardly stumbled into our new role as planetary managers. We are like a young teenager who has undergone a massive growth spurt and has tremendous physical power, but our intellectual, emotional, and cultural maturation is still catching up. We still practice racism, oppression, and war. We tend to be reactive and not proactive. We are quick to deny responsibility, and when resources are scarce, we revert to tribalism. Such instincts served us well back when every day was a struggle for survival. But this toxic mixture could be catastrophic for us this century as we add 3 billion people to a planet that's not getting any larger and whose peoples are well armed. Edward O. Wilson famously frames our crisis this way. He said, "The real problem of humanity is that we have Paleolithic emotions, medieval institutions, and godlike technology." So unless we want the next few decades and centuries to really suck, we need to grow up. Now, I don't say these things to scare you. Fear is actually very counterproductive. Fear causes people to shut down and disengage. They ignore the problem or rationalize its denial. Fear also engages our primitive instincts, which cloud our ability to think critically. It inhibits us from solving problems creatively. So no, my goal is not to scare you, but I do want you to share my concern and then join those of us who are seeking ways to make the situation better. I do this because I believe each of you can play an important role in this epic journey of ours. However, I will warn you that getting woke to our global crisis, environmental crisis, is emotionally taxing. There will be anxiety, fear, guilt, anger, and a sense of helplessness. And if you don't have an antidote for these negative feelings, you are vulnerable to depression, burnout, and apathy. Everyone will need to find their own strategy for coping, but that's a whole different conversation for another day. As for me, I'm doing okay. I do worry a lot about the future, not just for my children and the people I love, but for everyone, including coming generations. I also worry about our impact on other species. Causing their extinction is immoral in my view of the world. And I get really frustrated with the denial, ignorance, bigotry, and selfishness that holds our species back. So to counteract the negativity, I do a few things I'm going to share with you now. Foremost is that I find the courage to face these problems. My courage comes from knowing that my most important personal goal is to leave this world in a better place than when I came in. I also find hope in our more enlightened human instincts that shine through every day. We can be kind to complete strangers. We can be selfless and compassionate. We can make good long-term decisions. And as we've done time and again, we can pull together to accomplish truly amazing things. I also seek wisdom and inspiration from those who are rallying to address injustice, climate change, and environmental decay. I am most inspired by ordinary citizens using their talents and resources to do good. Children and teachers, artists and writers, nurses and doctors, scientists and architects, religious leaders and retirees, businessmen and women, farmers and laborers. There are tens of millions of them already, and more join their ranks every day. Real change will come from a groundswell of action from ordinary people like us, concerned about our collective future. I am convinced it will not be solved by those in charge. As beneficiaries of the status quo, they have the least incentive to change. Finally, and perhaps most importantly, I fight the negative by allowing myself to get excited about our future. Ironically, the climate we have changed is now forcing us to change in response. So this presents an opportunity to improve how we live with the planet and how we live with each other. This is why the book I'm writing is not just about the gloomy challenges that we and our rivers are facing. It's also about solutions, exciting solutions that can get us to a much better place than we are today. I'll share some with you now. While I don't have time to provide context for them all, I'll share them anyway to give you a taste of what our future could look like. First, I see a future where the peoples of the world unite in curbing greenhouse gas emissions by weaning ourselves off fossil fuels well before mid-century. This must happen, because if we delay much longer, the results will be truly catastrophic. To get there, we'll need everyone's cooperation. That means creating space at the decision-making table for those who have long been excluded. Not only is this fair, but more diversity means more buy-in and more creative solutions. Social justice is essential to success because the people who are being harmed first and most by climate change are not the ones who created the problem, and they know it. As for our rivers, I see a future where water efficiency policies and new technologies ensure we have enough water. Many dams will come down for all the reasons discussed. Remaining dams will be better managed to sustain biodiversity and natural river processes. Coal plants will close, freeing up water for rivers. A transition to renewable energy leads to cleaner air and water, thus ending pollution that currently kills tens of thousands of people each day worldwide. Cleaner rivers that are flowing more freely will allow fish and mussels populations to rebuild. Rivers will once again shimmer each spring with migrations of sturgeon and shad, much to the delight of anglers and wildlife enthusiasts. Mussels will once again pave the bottoms of our streams and help keep them clean. We'll stop living in the river floodplains, helping people and businesses resettle on higher, safer ground. We'll also improve our own habitat, the city. We will lessen the twin dangers of rising urban heating and stormwater flooding by bringing nature back into cities. More green roofs, trees, parks, and open spaces to absorb rainwater and cool us down. Mass transit and safe walking and biking paths will get us out of our cars, reduce carbon dioxide emissions, and make us healthier. Cities will become safer, more enjoyable, and the rivers downstream will benefit from less pollution. Things will be especially challenging on the coast as the cycle of destruction and rebuilding quickens. This will strain governments, the insurance industry, residents, and businesses. So rather than rebuild in the same places and in the same ways that made us vulnerable, we'll shift where we live and how we live on the coast. We rebuild to increase resiliency, which means recovery is faster and less costly. Some low areas will simply need to be abandoned, while others deemed too important will need to be armored or raised. Many cities will follow the current leadership of Norfolk, Virginia, and address social inequality while they adapt to the rising waters and other environmental challenges. With rivers running more freely, sediments will flow to the coast and help build protected marshes and barrier islands. Fresh water will push back the salty tides long enough for our coastal ecosystems to adjust to increased salinities and sea levels. We will partner with nature to prepare for sea level rise. In many areas, building swamps, marshes, and oyster reefs is already more effective and much cheaper than constructing walls to keep out flooding. This will be a win-win for coastal ecosystems and the economy. So that's a taste of the future that we can have. Climate change is forcing us to alter how we live. There is no dodging this reality. Significant change is baked into the climate for the next century and beyond. However, we do have choices in how bad it gets and how we respond. If we proceed like we usually do, we'll bumble our way through the transition to the Anthropecene, and it will be messy and costly. Many species and ecosystems will disappear, and there will be significant social disruption. Or we can get informed, get creative, and work together to lessen climate change and adapt to it gracefully. And though it will be a rough ride, we can make the best of it, and by some measures come out ahead. So I'll end with a question for you. Who's with me? So I've left a significant chunk of time for questions and discussion. It's, we're right on schedule. Good. So take any questions. Anything about science? Anything about envisioning the future? Nico.
Is there any evidence that the removal of dams in the last decade has increased fish and population?
Yes. There's been, on many of the dam removal projects, biologists have studied the before and after effects of the dam. So they'll go in and they'll measure like populations of fishes and snails and mussels before the dam, and then afterwards they monitor it. And it's cut and dry. It's very clear that the benefits for river species. Good question. Yes?
So I just wanted to know what your thoughts were on farms and how they help places like the sturgeon population, whether they're looking into farming sturgeon for patio or not.
Sure, yeah. So So the question was about fish farms. Are they good or bad in all this? How does that work out? It really depends on two things, the species, and it depends on the context. So for example, fish farms for Atlantic salmon in Puget Sound, which is on the west coast, are a disaster. Storms disrupted the cages while I was up there in Seattle for a sabbatical year, and the Atlantic salmon are out there mingling with Pacific salmon, and that's really bad for the genetics of the Pacific salmon. On the other hand, there's places where we're raising catfish here in the south, we're raising tilapia, and it's done sustainably and safely, and it's actually a really low carbon source of protein. So it really depends on the context. Yes, sir?
Are there any efforts to reintroduce sturgeon in the mussel environment, or vice versa, where the sturgeon are in adequate food sources and other supplies?
Sure. So the question was, are there efforts to reintroduce sturgeon? There was some discussion of breeding sturgeon and releasing them into the wild about 15 years ago or so. But what we've learned from similar projects with other species is that captive raised fishes are dumb. They grow up in a tank and they don't learn how to evade predators. They don't know how to respond to natural cues. And so fishes that have been marked and released tend to have very low survival rates. And there's all sorts of a whole other cascade of problems. So the most effective strategies are the ones that rebuild the environment so the fishes themselves can come back on their own. So we provide them the resources they need. And that's the strategy that's being pursued for sturgeon, Atlantic and Gulf sturgeon. But other species, for some species, like you go to the Pacific Northwest, and it's like every 5 miles there's another salmon farm, because they're having to restock these rivers for a lot of economic reasons. Salmon are such important, and the dams have had such an impact that they have to keep supplying salmon into the rivers. Shane.
Let me ask you a big picture question, and perhaps a controversial one. One key variable in the vision of the future and playing out right now, which you didn't mention, but I suspect is in your mind, is population growth. How do you envision that needing to be on the table? In other words, partly human behavior, human reproductive behavior, and all the systems associated with that. Patriarchal systems, drive down some religious systems. Because in your future, people are living longer and healthier, which means there's more people, which means there's more consumption. So it seems to be like an inevitable cycle, unless you hypothesize some grand technological solution, which is usually the edge. That hasn't been the case so far. Yes.
Yeah.
So I'm wondering at what level we need to have policy about does that need to be on the table for conversation?
Oh, there's a stinker of a question.
It is.
So to repeat for people in the back that may not have heard, the question is looking ahead at population growth and how does that factor into all this, to just simplify. So we're at about 7.7 billion people right now on the planet. And that number just keeps going up. And it's projected to top out and plateau somewhere around 10 to 11 million people by mid-century. So that's when most of the students in the audience are roughly going to be my age. So imagine 10 billion people on the planet. The good news, and there is good news here, is that the rate of population growth is slowing down. And the reason it's slowing down is because women are being empowered through education and getting involved in the workforce around the world. And as women are getting educated and involved in the economy, they're having fewer children, they're spacing their children out more, and their children are living longer and having healthier lives. So it's a win-win situation. There are hard caps on how many people can be sustained on this planet. There is only so much, so everything is dependent on photosynthesis, the capture of sunlight by plants. Everything, all the food that you will ever eat eventually goes back to the sun as a source of energy. And there's only so much sunlight that reaches the earth each day, and only so much photosynthesis can be done. There are hard caps. We don't know what that hard cap is. We call it in ecology a carrying capacity. But it's a lot of estimates put it around 11, maybe 12 billion people or so. But the long term, there are people that make a profession, a career out of studying population growth. And the long-term projections are is that we're going to be peaking around mid-century or so, and then there's going to be a decline in population size. So there's actually a good bit of good news there. We just got to wait for it to come. There are actually, and I've been listening to a lot of conversation amongst millennials in the U.S. that are reconsidering how many children to have, and in some cases, whether to have children at all, for a variety of reasons, including facing a very challenging future for us all. Other questions? Yes, hey.
How would you address the carbon emissions that are arising from like industrial countries like China or India, where a lot of
So how am I going to solve the world problems? Yeah, these are great questions. These are absolutely great questions. So to repeat the question and make sure I get it right, Ricky, how do we address the growing industrialization of China and India, which are, of course, the most populous countries on the planet? This has been one of the major obstacles to getting the nations of the world to agree on a climate plan. Because the developing countries of the world are looking at Europe, they're looking at the US and Canada, and they're like, we want to live like you guys. It looks pretty sweet from our perspective. And they want to industrialize just as we have done. But at the same time, now over here in the US and in Europe, we're like, no, we can't do it the way that we did it, because it's going to trash the earth. And that tension between developing countries and developed countries has been a source of frustration, because the countries haven't been able to agree on, for example, how to curb carbon dioxide emissions. The best plan that they've come up with so far has been the Paris Accords, where countries volunteer to make sacrifices, to make changes in their economy and the way that they do things, in order for the planet to not heat up more than 1.5 degrees Celsius, which is the target value that we really don't want to go beyond. And of course, there's one country in the world that hasn't joined the Paris Accords, but is trying to extract itself from the Paris Accords. That would be us, thanks to the current presidency. But the good news there is that we can't officially pull out until after next election, next presidential election. So, other questions? We've still got a couple more minutes left. Yes, sir.
Similar to now bringing some of the work that we're trying to create nature preserve to help preserve endangered species like garlic. Is there any presence of certain populations in nature preserve habitats like the Southeast or the country you're aware of that help maintain some percentage of populations?
Yeah, so the question was, do we have safe havens for fishes like sturgeon? And the answer is yes. And in fact, the Swanee River, I showed you a picture of early on, they're reaching their carrying capacity in the number of sturgeon that river can support. And guess what? The Swanee River is one of the only rivers with a sturgeon that doesn't have dams on it. So that plus some other reasons have helped the sturgeon population recover there. It's a protective species, and many of the places, estuaries where they hang out during the winter, and some of the places they go in the rivers are protected. So, they're still mingling with industrial pollution and ships and barges and stuff like that all the time. And in some cases, they actually collide with people. They jump out of the water and actually quite tragically, and hit boaters sometimes. So there actually have been some deaths and injuries as a result of that. So we got to share the planet. And there are places where sturgeon do have safe haven.
As the official timekeeper, I will say, let's give that. Okay.